Hey everyone, Morgan here. So we are looking at page 11 of the Thermochem outline for AP Chem, and this is a continuation of the idea from the previous page. We're talking about enthalpies of formation, and we are going to use them in a scenario that is referred to as products minus reactants. Because enthalpies are a state function, we really only care about initial and final values. So that allows us to use this concept called products minus reactants. Now, you can get a copy of the thermotables from my webpage that list the heats of formation for all of these species that are involved here. And we're going to balance our first equation like that. And we're going to look up the heats of formation for both of these products. Delta H naught reaction is going to equal, since I2 is in its natural state, its heat of formation is 0, plus 2 times the value for Br minus aqueous, and that is negative 120.9, minus, now for the reactants, Br2 gas, 30.91, plus 2 times the value for I minus, which is negative 55.94, and all of this is measured in kilojoules per mole. And when I ran that through my calculator, I got negative 160.8 kilojoules. And the reason I'm saying kilojoules rather than kilojoules per mole is because when I multiplied by 2 moles, moles canceled. I multiplied here by 1 mole, moles cancels. We're just left with kilojoules. All right. Now, for my next one, I'll balance by putting 2's there and there. And the heat of reaction, or enthalpy of reaction, delta H naught Rxn equals 1 times the value for CO2, and that is negative 393.5 plus 2 times the value for the water, which is negative 241.83. And as always, tables from different sources might have slightly different values here, nothing to worry about. The value for CH4 is negative 74.87 plus, and 2 times 0 because oxygen gas is its natural state, all in kilojoules per mole. And on my calculator, I got negative 802.3 kilojoules. All right. This next one, let's see, I put a 2 there and I put a 2 there. Delta H naught reaction equals, now I'm going to need this plus that, which will be 0 plus 2 times that. So for the zinc 2 plus, it's negative 152.4 plus 0 plus 2 times, and for Cl minus, that's negative 167.46 minus zinc solid, that's actually a 0, that's its natural state, plus 2 times the value for HCl, which is negative 167.46. Kilojoules per mole for all of these. And this ends up equaling negative 152.4 kilojoules. Okay. We'll do one more like this, and then we're going to move on to a slightly more useful approach to it. So 2 HCl, 2 on the NaCl, 2 times the value, 1 times the value for this, 1 times the value for this, 2 times the value for that. So what I'm going to end up with here is negative 393.5 plus negative 241.86 plus 2 times 411.1 minus negative 1130.8 plus 2 times the negative 167.46, and this whole thing equals 8.16 kilojoules. These were all kilojoules per mole. Now, that's nice. That's it's a good technique. But the AP exam tends to do something a little bit different with us. So let's imagine we have this one with a 2 there, by the way. Okay, that's right. I can do a little bit of arithmetic here and say that 2x is going to equal 9.16 plus 57.24, or that 2x is going to equal 66.4. Add those together, and x itself is going to equal 33.2 kilojoules. And it's actually per mole. So that's what's more often going to happen to you on the AP exam. One of them will be missing. Hopefully it won't be as complicated as this. Usually something pretty straightforward like that. Okay, thanks for tuning in. This is Morgan signing off.